Thank you so much, Sarah, for that lovely introduction. And I'll just check that everyone can see and hear me okay. Thumbs up. Perfect. And a warm welcome to everybody joining us online this afternoon as well. As Sarah mentioned, today I'm going to be talking about the promises, the pitfalls, and the perils of artificial intelligence in libraries and other GLAM institutions. You've probably heard the hype. Machines that make decisions, physical systems that are increasingly automated, algorithms that summarize documents and generate their own text. How these tools make our lives more efficient, quicker, seamless, frictionless. Those capabilities are no longer science fiction. The future is already here. The future is already here, but it's not evenly distributed. It's not fair. It's not inclusive, and it's not kind. It doesn't always align with the values that we hold, that our institutions hold, or that the communities and the publics that we serve hold. We've all heard the horror stories. Facial recognition that labels African American people as gorillas. Speech recognition that doesn't work if you have a non-white, non-privileged accent. Machine translations that lose so much context, so much nuance, so much cultural heritage in translation. We've heard the bad English memes, where things are poorly translated into English. But consider the flip side. What happens when we translate from English into other cultures, into other languages, and we let a computer do it? My message today is deceptively simple. The perils and pitfalls of machine learning and artificial intelligence are all about data, decisions, and dynamics. And today I'm going to walk through some conceptual tools that help you ask the right questions about data, decisions, and dynamics. And we're going to take an overview of data. I'm going to help you think about data a little bit differently. I'm going to cover agents, and I'm going to give you a brief introduction to machine learning. And as a special surprise, I'm going to turn you all into machine learning agents. That's a little bit later on. Library systems are dynamic systems. And I'm going to help you help you find where you can intervene in those systems so that together we can build a better future. But before I do that, there are three things I want to do. I want to acknowledge country. I want to say some thank yous. And I want to tell you a little bit about myself. So firstly, I want to acknowledge that we're meeting here today on the lands, the unceded lands of the Wurundjeri people. I want to acknowledge that I've travelled over Wadawurrung country in Geelong to be here today. I pay my respects to elders past and present, and I especially acknowledge any First Nations, Pacifica, and other Torres Strait Islander and Indigenous peoples that we have here today. Secondly, I want to say a huge thank you to everyone here in Naarm in Melbourne and to everyone joining us online. I want to say thank you for isolating, for locking down, for wearing masks, for getting vaccinated, for eating too much sourdough. It's because of your actions. You helped keep everybody safe. And there are people here today, like me, who wouldn't be alive if it wasn't for your actions. Thank you. Thirdly, I want to tell you a little bit about myself. Like many Australians, I'm a child of two countries. My incredible mum was born near the Otways in Geelong. That's where she grew up. And it's from my mum that I have learnt the incredible value of education, of the internet, and of libraries, and how important they are to social mobility. She's an incredible lady. My father has long since passed. But my father's country is the north of England, in Northumbria. Think Billy Elliot country. Think Vera. And I believe Hannah's from around there as well. And that's where we're going to start today. Now, there's a beautiful and terrible story behind this poster. And I see from some of the looks in the audience that some of you are already familiar with this story. In England, in 1939, there was a huge climate of fear. A fear of World War II, massive air raids, bombs coming from the sky, no one knew when. A fear of invasion by Axis powers. And the British government created a propaganda campaign to help lift morale, to help tell people it's going to be okay, to keep calm and carry on. These posters, there were, off the top of my head, there were over 2 million of them produced. These posters were lost to history until in the year 2000, in an old bookstore that was built above a railway station in the Northumbrian town of Alnwick, 2 streets away from where my auntie lived in Northumbria. So that's where we're going to start today. And you might be asking, Kathy's gone crackers already, what's she talking about? What on earth does keep calm and carry on have to do with data, decisions and dynamics? Well, it's that backdrop of war, that backdrop of fear, of being bombed, that led to the birth of cybernetics. Cybernetics as a discipline was born of fear. And cybernetics thought about how might we sense our environment? How might we sense the trajectory of those fighter planes and be able to make decisions and respond and send anti-artillery aircraft fire up? How can we be dynamic about this? How do we gather data? How do we make decisions? How do we be dynamic? Many great minds have contributed to the field of cybernetics. A few hours south of Alnwick, W. Ross Ashby, who was a psychiatrist working with mentally ill people, was working with adaptive systems, systems that can sense change, make decisions and respond. And Ashby came up with a homeostat, this device. It's a device that is meant to be resilient to shocks to a system. It can sense when there are changes, it can sense data, and it can make decisions about how to respond. It's a dynamic system, and you see the theme that I'm riffing on today, don't you? Data, decisions, and dynamics. Half a world away, some of you might also be familiar with the work of Norbert Wiener in the US. So Norbert Wiener's work was also centred around identifying the trajectory of fighter aircraft and finding out how we can respond. And Norbert Wiener also built a dynamic system. This is Pella Miller. Pella Miller had a light sensor at each side, and she could see and sense light. And depending on the direction of voltage, Pella Miller would be able to either run toward the light like a moth or run away from the light like a bedbug. So Pella Miller was this moth-bedbug hybrid. And now what I'm going to do from Alnwick in the 1940s, the country of my father, to keep calm and carry on posters hidden above the Alnwick railway station, the backdrop of war, the birth of cybernetics, I'm going to jump forward 70 years to the present day, to emerging technologies in libraries and GLAM institutions. And we're going to dig a little bit deeper into those emerging technologies. We're going to rip back the curtains a little bit, and we're going to find out what makes them tick. And you'll start to see how the early work of cybernetics, the work of W. Ross Ashby and Norbert Wiener with dynamic systems, is just as relevant as it was today, as it was in the 1940s, 70 years ago. And to do that, I'm going to swing back from Alnwick, back from my father's country. And I'm going to come back to my first country, to Australia, to Victoria, to my mother's people. And I'm going to use an Indigenous example here, and I want to be very clear that I am not Indigenous. But I think it's an incredibly illustrative example of the perils and pitfalls of some of the emerging technology that we have today. Some of you might be familiar with this. For context, Bunjil is a character in the Indigenous creation stories of southwest Victoria. Very important to the people of the Kulin Nation, the Wadawurrung, the Boonwurrung, the Jabwurrung peoples. You can often see representations of Bunjil around Victoria. There's a 23-metre high statue of Bunjil in Melbourne, and if you're ever in Geelong near the Yuyangs, you can see a glyph of Bunjil carved into the countryside. Bunjil is often represented as an eagle. So if we think about automated resource description technologies for a second, how might they describe Bunjil's cave in Garryward in the Grampians near Stawell? A motif that has Indigenous heritage that comes from a different language. How do we think an automated resource description technology might handle that? Well, I did what all good nerds do, and I ran the model to find out. And I need to give you a content warning here. Anyone in the audience who is of Indigenous heritage, and particularly those of the Kulin Nation, may be offended by what comes next, so I need to provide that warning. A cave with a painting of a giraffe in it. I'm not quite sure how the AI got giraffe out of that, but we're going to find out. The future is already here, but it's not evenly distributed. It doesn't work for everybody. It doesn't work for every culture, and it doesn't work for every language. Data is crucial to machine learning technologies, how they learn. Problems with data flow into problems with decisions and decisions that are made. And problems with data can have incredibly dynamic and often very disparate consequences in the real world. And it can have cultural and it can do cultural damage and cause incredible trust issues with institutions. What might happen to an institution who published this automatic description? Would you trust that institution? I'm not sure I would. So why might this automatic description generator have predicted giraffe for Bunjil? And the answer lies in data. Many of us work with data in our everyday lives, in pandas data frames, in SQL databases, I'm playing to the audience a little bit here, in cataloguing systems. We're familiar with one description of data, an item of information, a fact, a statistic. But data is a lot more nuanced than that, and I want to unpack data a little bit. Data is a representation of a phenomenon. Data is a description, an interpretation of characteristics, objects, and events in the world. When I think about the temperature, each of you, because I suspect most of you grew up with Celsius, when I think of temperature, you'll immediately get a figure in degrees Celsius. A thermometer has measured that air temperature, so it's been sensed in the world. The data has been captured from the world. And then it's interpreted in Celsius, or if you're in America, Fahrenheit. I don't know what England's using at the moment, and I'm not sure that they know either. So data is a representation of a real-world phenomenon. The speech sounds that I'm speaking through the lapel mic today are captured. They're captured through the microphone. And then they're processed and interpreted. And I'm guessing that Corey up there has a digital signal processor doing some of that work. Thank you, Corey. Data is a representation. It's an interpretation of a real-world phenomenon. Most of us will be wearing clothes today. I can't speak for the folks online. I hope you're all very warm. But when we think about how we describe our clothes, am I wearing a tunic or a blouse? We've had pub fights over that, haven't we? No tunic, no blouse. It's a category. What colour is the top that I'm wearing? Is it black or tan or both? What size is it? Let's not go into that one, hey? My point is this. We apply categories, we apply labels, we apply annotations to data. We apply interpretations to data that happens in the real world. Another really interesting example is gender. It's only in recent years that we have started to reconceptualise gender not as a binary, but as a spectrum. And we've created space for people who don't identify with the gender binary. Gender is a category, it's a label. And I want us to keep this in mind when we start to think about the future and the future libraries and the future GLAM institutions we want to create. We create the future through data and the categories and the annotations and the labels that we place upon that data. And I think this is a very good example of a gender classification form. This is from Instagram. And what it allows people to do is to use gender as a free text field. And I want to acknowledge Brianna Lawyer's early work here that she did about 10 years ago at a bar camp, where she stood up in Geelong and she said, gender is a free text field. We should be using free text for gender. And here, 12 years later, we're starting to see that thinking come through. And when we start to think about this example, I want us to flip back to Bunjil's cave in Garrawerd. And what categories might have gone into the automatic transcription generator that generated the description? A cave with a giraffe in it. It might have had a category for paintings. It clearly had a category for animals and giraffes. But it might not have had categories for Indigenous motives. It might not have had categories for Warawarang or Boonwurrung or Jabwarang language. The categories we create, the annotations we make, the labels we stick on data create our futures. And when we think of artificial intelligence, I suspect many of you have an image in your mind of a robot, perhaps a host from Westworld. Or it could be WALL-E if you have more of a Disney persuasion. And in our cultural imaginary, there are all sorts of things packed into that imagination. The artificial intelligence usually has a physical manifestation. It's able to determine its own goals, its own objectives, and it's able to sense the world and make decisions and act upon them. It's able to leave the park in the Westworld universe. Like WALL-E, it's able to find a planet with a green chute on it. It's able to have incredible generality about how it can operate. That cultural imaginary gets some things very right. That artificial intelligence is about data and making decisions and taking actions. But there are some things it doesn't get as right. It gets wrong. Artificial intelligence doesn't always have a physical manifestation, and it often works in very narrow ways. So because artificial intelligence is so packed with preconceptions and different people have different understandings of what artificial intelligence is today, I'm not going to use that term. I'm going to use something a lot more specific because I think it helps make things clearer. I'm going to use the term agent. I love saying it like that, agent. An agent is an entity that senses its environment, gathers data, and is able to take actions on that environment. Data, decisions, dynamics. Now, agents usually have a very narrowly defined goal. Win a game of chess. Give me a good recommendation of what to binge next on Netflix. Create a description of a cave with a painting in it. Machine learning is full of acronyms and jargon. And instead of diving into those acronyms and jargon today, what I want to do is demystify things, explain them in really readily accessible terms. And you have already seen a lot of agents in action. You use them every day. And I want to spend a bit of time unpacking some of those agents. what they do, how they use data to make decisions, and some of the perils and pitfalls that come with that. The key thing that they have in common is that they all use data to make decisions. And how they use data and the type of data they use matter for our future, for our futures. And what better way to start than by baked goods and corgis? So many of you will be familiar with this meme. And sorry, Corey, I have to apologise. This is incredibly close to my heart. I have a corgi. His name is Tim Tam. He's on Twitter. You can follow him. He's at Tim Tam Corgi. So one of the tricks that I play, I try and get a corgi into every slide deck that I do. So yes, we're going to start with corgis and loaves of bread. So corgi or loaf is a classification agent. Its goal is to classify data. Is it a corgi, or two corgis, or is it a loaf of bread? So the agent is making a classification decision. It's looking at data, the image, and it's making a decision. Corgi or loaf of bread? And sometimes these agents, these classification agents, get it very wrong. We've seen the facial recognition technology that doesn't recognise African American faces particularly well. It puts them into the wrong category, or even worse, it labels them as gorillas. It can get it very, very wrong. And that tells us a little bit about the data that's being used, or the categories that are being used to train these agents. There are also other types of classification agents. How many people have a voice assistant either at home or on their phone? Quite a few skeptics in the room, that's probably a very good thing. I promise I'm not going to try and wake up your voice assistant. Your voice assistant has what's called a wake word classifier on it. So when you speak to your voice assistant, "Okay, computer," if you're a Star Trek fan, what it's trying to do is classify. What was just spoken, was that a wake word or not a wake word? It's making a classification decision. So we're already using a lot of these agents in everyday products in our everyday lives. We just don't think of them as agents. And the reason for this is so that we can, put a whole heap of jargon around it and charge people a lot of money by saying things like, "now with added artificial intelligence," or "now with machine learning." So we put a whole heap of jargon around it when under the hood these concepts are very, very simple. So these examples, corgi or loaf of bread, are quite benign. But you can immediately see how classification decisions can become incredibly detrimental. Should this person be given parole? Should this job interview be cancelled or be given to an applicant? Should this person be accepted into college? All of these are classification decisions, but they have incredibly, incredibly real-world consequences for people. Decisions are made on data, and the consequences of those decisions are incredibly dynamic, and they ripple through the real world, and they touch real people. Data, decisions, and dynamics. I'm going to also have a look at predictive agents. So most of you will use this on your phone. You will have something called autocorrect. Sorry, I meant autocorrect. And one of the things that you will see, if you swear a lot like a hypothetical person, one of the things that you'll notice in your, someone's nodding there, one of the things that you'll notice in your phone is that it won't autocorrect swear words, shot. It won't autocorrect to a bad word. People have made decisions about what data the autocorrect agent is using. It won't let you autocorrect to a bad word. Another good example of a predictive agent, do we have anybody from Canberra in the house? Hello, welcome. You'll remember last year, This is a beautiful story, this one. So last year, I was actually in Canberra at the time that we had lockdown, and Andrew Barr, who's the Chief Minister of the ACT, was congratulating the folks of the ACT because we'd done a good job. We'd gotten vaccinated, we'd gotten masked up, we'd isolated. Walks up onto stage and he goes, "Good job, Canberrans." Automatic transcription comes up, Canberrans. This is an example of a predictive text fail. And there's a beautiful story behind this. Ken Behrens is actually a wildlife photographer from Madagascar. He might do giraffes, I don't know. But the story behind this, because he's so famous, the name Ken Behrens appears in things like Wikipedia and news articles. So the phrase Ken Behrens appears quite frequently. Now, if we think about Canberra's capital city of the country. It appears quite frequently in Wikipedia, in news articles, on things that might be used to train an automatic caption tool. But if we think about Ken Behrens, the demonym, it hardly appears at all. And that, folks, is why we have the Ken Behrens meme. Because Ken Behrens, the word, doesn't appear in the data on which the automatic transcription tool was trained. So thanks to the perils and the pitfalls of artificial intelligence, we've got ourselves another Canberra meme. So speech recognition works in a very similar way. I've asked before if anyone has a voice assistant, not many people do. But if you do go to a house that has a voice assistant and you're talking to it, pay careful attention to who it talks back to. Does it recognise men better than women? Does it recognise adults better than children? Does it recognise more senior aged people better than it does people of other ages? Keep it in mind because it will tell you something about the data that it's been trained on. So it's a little bit about predictive agents. Some agents are generative. And I think Bonnie Wildley gave us a beautiful example of DALL-E in her talk. Absolutely beautiful. What a generative agent does is gives us an output that matches a prompt and input. Now, in the case of GPT-3, I didn't want to do a live demo of GPT-3 because it's hard with AV, but I have access to GPT-3, so I'm happy to take anyone through. What happens with GPT-3 or with DALL-E is that you give it an input as a prompt, and it tries to generate an image or text as output. And now I'm going to loop back to Bunjil and Garraword and Bunjil's cave again. Automatic descriptors are generative. They are agents that generate output that matches the prompt that was provided. And the key difference is that the prompt is just an image. And we can start to see where that model got it wrong, where that agent got it wrong. If it was trained on images from Africa and images of giraffes, but it hadn't been trained on data from Garraword or data from the Kulin Nation. The future is already here, but it's not evenly distributed. It's not always inclusive, and it's not always fair. So you might be wondering, well, how do we train these agents? How do they make those decisions? And this connects us to machine learning. And I make a promise here to you right now, no maths at all. No maths, I promise. So regardless of the type of problem that the agent is solving, whether it is a classification problem, corgi or loaf of bread, whether it's a predictive problem, Ken Behrens or Ken Behrens, or whether it's a generative problem, that agent learns from something. It learns from data. And the way that a model learns, and I'm grossly oversimplifying for any machine learning folks in the audience, I recognise that. The way that an agent learns is through reward and punishment. Sorry, I was told not to do the evil laugh, I apologise. So agents are trained through reward and punishment. If it makes a decision and it gets it right, it's given a reward. And if it makes a decision and it gets it wrong, it's given a punishment. Now, those rewards and punishments vary by algorithm, but that's basically what happens when we train a machine learning agent. And Sarah, you ready? Thank you. And now we're going to play a little bit of a game. I'm going to turn you all into machine learning agents, and I'm going to see if I can train you. Sorry. Now, there was a game that we all used to play in primary school, or for some of us that was many years ago. Now, remember the game we used to play where we're going on a trip and we're able to take something with us? Now, you don't have to remember everything that you're going to take with us. What I'm going to get you to do today is to try and spot the pattern. And Sarah's going to grab guesses from people online. So it's going to work like this. You're going to shout out a guess of something that we can take on our trip, and I'm going to give you either a reward, I'm going to say yes, or I'm going to give you a punishment. Sorry, it sounds evil when I do that, doesn't it? I'm going to say no. And then when you think you found the pattern, yell it out. So we're going to start. Can somebody give me an object that we're going to take on our trip? And I'll tell you whether we can or we can't. Sorry, I missed that. Wallet. Yes, you can take your wallet. I heard lollies. Yes, you can take your lollies. Water bottle. You can take the bottle but not the water. No, you can't take the fridge. Sorry? Does it have an L in it? Good guess, but no. Another object. Yes? Oh, well done. Round of applause. Congratulations. I think we have a budding machine learning engineer in the room. So you can see what was happening there as I was training you, right? You were taking guesses, you were thinking about what does it match, what pattern might it match. Oh, I'm so sorry. Apologies for the microphone. The rule was it has to have a double letter sequence in it. That's why you could take the bottle but not the water, and why you could take the lollies but you couldn't take the fridge. So that was a lot quicker than I was expecting. But you can see the pattern there. The original guesses were a little bit hit and miss, but we started to get things that were closer and closer and more accurate. We got lollies and we got bottle, and then we got the pattern matched. So if we think about training a machine learning agent, and we want it to be really, really good and really, really accurate, it's really simple, isn't it? We just throw more data at it. Dead easy, simple, problem solved. Not quite so fast, sorry. Couple of things that throw a spanner in the works. Machine learning agents are usually trained for a period of time. So we do a training sequence, and then it's like kicking them out after high school. They go out into the world and they make their own way. So once a machine learning agent has been trained, after that point when it's deployed, it's no longer learning. It's no longer getting the reward or the punishment. So it's static, it's fixed at a point in time. And when a machine learning agent is making these sorts of decisions, it's doing what we call inference. So an agent has a training phase. Think of that as, high school for the machine learning agent. And then it has an inference phase where it has to make its way in the real world. And you can start to see what might become a problem here. If the data that the machine learning agent was trained on and where it's deployed, that real-life scenario, if those data sets don't match, or they're not the same kind, or they're unmatched in other ways, the machine learning agent isn't going to perform very well. If you have trained your machine learning agent on cave paintings in Africa where there are giraffes, and then you deploy your machine learning agent in Garryword, in the Grampians, in the land of the Kulin Nation, now we can start to see why it got Bunjil's cave so very, very wrong. The future's already here, etc., etc. There's another final point that I want to underscore with machine learning. Agents are stochastic. And what I mean by that is they work on probabilities. And you can see the second corgi slide I've managed to get into the deck. They aren't rule-based. They get it wrong sometimes. And when the agent is just beginning to learn, it's going to get it very, very wrong until it gets more and more examples to train on. But even if it trains on a huge amount of data, if that data doesn't match the real-life scenario, it's still not going to be particularly accurate. There's always an element of randomness with machine learning agents. And I can see Justin in the room somewhere. Hello, Justin. Justin has a whole talk on this this afternoon. So if this area really interests you, please go to Justin's talk. And now I'm going to jump back 70 years. To keep calm and to carry on, and to Anik and my auntie's house and W. Ross Ashby and the birth of cybernetics. And we can start to see the through lines here. These were cybernetic systems. They sensed their environment. They gathered data, they made decisions, and they took action. They were dynamic systems. And now what I want to do is show how the library is a cybernetic system itself. And that's the key tenet of this document. It's a research collaboration between the ANU School of Cybernetics, where I'm a PhD candidate, and the National Library of Australia. And it frames libraries as cybernetic systems. Systems of many agents doing different things. Systems of people and the built and natural environment in a continuing interplay of data, decisions, and dynamics. And now that we know more about data, decisions, and dynamics, we can start to see how we might intervene in a library system. So if we think about the library or other GLAM institutions as a dynamic system, we can start to see where we might want to intervene. Do we want to intervene in the data that the agents are capturing? Do we want to intervene in the decisions that they're making and the dynamic impact that they're having on people and our stakeholders in the library? Do we want to intervene in the way that those decisions and those dynamics are impacting on the built and natural environment? If we map our institutions as systems, as dynamic systems, then places to intervene start to become clear. Dynamic systems change the nature of the library itself, how library publics are engaging with content, what content is surfaced, what content is reified or valorized, what content is oppressed, what content is erased. Imagine a recommender system that only recommended the most popular content, and because people borrowed the popular content that was in the recommender system, only the popular content got borrowed. That's a dynamic, that's a feedback loop. And we need to be able to identify those loops in our systems so that we can intervene in them, so that we can build the future libraries that we want to see. I want to close by offering a provocation. We've seen today how data, decisions, and dynamic systems help shape the world in which we live, help shape the services that we're afforded, and the decisions that are made about us. And I flipped the script a little bit and showed how libraries themselves are dynamic systems, how they create data, how they source data, how they make decisions about what content is presented, how that content is presented, to whom, and in what message, what medium. The libraries of the future are in your hands. You are an inherent part of the cybernetic library. The values that you hold, the decisions that you make, the dynamics that you bring to the table are an integral part of the libraries of the future, of the GLAM institutions of the future. And I want to be very clear about that. The libraries of the future will be built on data, and how that data is categorised, how it's labelled, how it's annotated. And the people that we need to do that have a rich understanding of culture, of history, of situation and context. We don't just need machine learning engineers and digital people. We need librarians and we need archivists to build the libraries of the future. And on that note, I'm going to say thank you very much for your time, and I'd be delighted to take your questions.
Thank you very much, Kathy. I might ask a question from the online audience first. What does reward or punishment mean for an AI, and what does it look like?
Aha, great question. So the way I'm going to frame an answer to this question, we've seen that there are many different types of machine learning agents, and there are many different types of machine learning algorithms. Now, each algorithm has its own reward or punishment scheme, and that can differ in incredibly granular ways. So the best way for me to answer that question is, it depends on the algorithm.
Are we training agents with captchas?
Yes.
That was an easy one.
Sorry, yes. Data, decisions, dynamics. Data, capture, decision, corgi or loaf of bread. Dynamic, yes, we're training captchas.
What are your thoughts on sites like iris.ai, which can supposedly let AI read and alert you to research? Is that good or scary?
Great question. I think the answer to that is both. So it's great in terms of being able to offload often menial tasks, or it's great in being able to automate tasks that might take a lot of time. But when we automate something, we always have to ask the question, what are we automating away? Are we automating away the nuance? Are we automating away the rich knowledge and history that an archivist has on a particular topic? What do we lose and what do we gain? So both.
What is the minimum technical skill set for librarians and that would want to participate in this space?
Great question. So I don't like to think in terms of minimal technical skill set. I think it's a reductionist way of thinking about the interdisciplinary skills we need for the library of the future. I'm going to reframe that question because as the speaker I get to actually answer the question I want to answer. So I'm going to reframe that question a little bit, and the question is really about if you're thinking about machine learning and you're thinking about artificial intelligence and how you might want to upskill from your current set of skills into that area, I want to give you one piece of advice. You already have those skills. I'm seeing looks of disbelief and shock. Machine learning is all about data. You work with data every single day. You know categories, you know metadata, you know what data belongs in what category better than many other people in this country. You already have these skills. What you can then add on top of the skills that you already have are knowledge of particular programs. And they have scary sounding names like PyTorch and TensorFlow and Keras. And that's a form of gatekeeping, and that's a talk for another day. But you already use cataloguing systems. How many of you can do SQL off the top of your head? You already have the skills for machine learning. Places to start is probably what people are looking for. There are several courses on Udemy and the online learning platforms. I know LinkedIn Learning has a lot. Start with Google's introduction to artificial intelligence. Doesn't contain any maths. There are several online free courses to dip your toe. Ask people for help. Start a study group. This isn't a case of, I don't know machine learning and artificial intelligence. It's a case of, I just don't know it yet.
And one last question. Would it be possible for an AI ML agent to be perpetually learning?
Excellent question. Short answer is yes, but there are constraints on that. So we saw before that a machine learning agent is basically fed data. Data is the input. The machine learning agent then has to go through a process of training. I'm going to skip over a few maths details here, but basically what a machine learning agent does when it's training, it does a whole bunch of calculations and computations. It adjusts things like weights and biases that are made on its decision. As our models get bigger and bigger and they're trained on more and more data, the calculations and the computations that the training of a machine learning agent takes a huge amount of computational power, or we call it compute. Now, there are limitations on how much compute we can use at the moment because compute also has other side effects. So compute takes a lot of energy, and if you're not using renewable energy, that has environmental consequences. So we're at a point at the moment where we have to balance the resources that are used in training an agent versus the continual updating of that agent. So like many dynamic systems, there's a huge trade-off there.
Wonderful. We're finishing off a little bit early, but I'm sure Kathy will be around to answer any questions that you might have. And thank you all, and we'll see you at the next session.
Thank you very much.